Just a minute. Suppose screen is visible to you. Yes, sir.
Yes, sir.
टूट गया
How we can solve this one?
कहते में लगता है टूट गई
Suppose uh, suppose here I am using most probably this particular example already given in the Morris Mena book. You can check. Okay. Now see here using the following input equation. That means based on the question only the question is providing only the input equation. Okay. Based on this particular input equation, we can derive the circuit. That means we can construct the circuit. After that, state table and state diagram. Okay. Only this particular equation is already given. But in this particular equation, how we can know which particular flip-flop actually we are using? Sometimes what happens, flip-flop also not mentioning. So you don't worry, because here you know D means what? DA is a symbol of D flip-flop. Okay, D means what? Here we are using only D flip-flop. So question is not mentioning, so you don't confuse, sir, question में तो flip-flop कुछ mention नहीं किया. So from the equation you can automatically know, yes, we can use the D flip-flop. So here DA, A is the subscript. Okay, so A means what? Whatever the output is generated from the D flip-flop, that is denoted as a capital letter A. So A XOR X XOR Y. Okay, this particular equation is already given. So here you can write, here D symbol implies the D flip-flop with output A. That means what is the output of D flip-flop? A. So we are writing as a DA. Okay, D subscript A. And the X and Y are the inputs to the circuit. So X and Y, we are providing two inputs to the circuit. So how we can derive the diagram? See here. It is that only how many flip-flops we are using? Only one flip-flop. So obviously this is the clock flip-flop. So obviously we are using the clock flip. Don't forget this one. This is the clock flip-flop. Okay. And suppose here we are assigning as a DA. Okay. So DA, and what is the output? Output, we can consider this one is the A. And if we are not writing second output, then it is no problem, but because by default second output is the A bar. Okay, A bar. So based on the equation, see here, A, we can connect here. Okay, we can connect here, and suppose this one is the X and this one is the Y, because two external input we are using X and Y. Okay, after that, which particular XOR? We are using the XOR gate, because A XOR X XOR Y. So what is the symbol of XOR? This one. Okay, and this one is directly connected to DA. So that is very simple. This one is the we can derive the circuit from this particular equation. Now how we can construct the just a minute. Someone trying to join? Okay. Now, next one is what? We are constructing the state table. This particular diagram you are getting or not?
Yes,
Yes, sir.
So, from this particular state equation, how we can construct the state table? Can you tell me how we can construct the state table? So, now can you tell me from this particular diagram, which particular variable we are considering as a present state?
A.
Yes,
A.
correct. Yes, correct. So what here we can write? So, we have when we are constructing the state table, we have 4 variables. Okay. So A for present state, X and Y are the inputs, and what? How? Why it is 4 variable? Because based on the equation, we have only 3 variables: A, X, Y. Why people are trying to join? Again, disturb again and again. Why they are not over here? नेक्स्ट टाइम से जो 10 मिनट के बाद लेट होगा ना, मैं उसको डिनाई कर दूंगा। लेकिन आप लोग का ये मर्जी नहीं है कि जब चाहे तब आप लोग ज्वाइन करेंगे, उसका एक पर्टिकुलर टाइम है। मैं लेट हो सकता हूँ, आप लोग लेट नहीं हो, मतलब हो सकते हैं, ठीक है। 9:30 में आप लोग 9 बजे क्लास है, आप लोग कोई स्टूडेंट 9:20 में ज्वाइन करेंगे, कोई स्टूडेंट 9:12 में ज्वाइन करेंगे। ये मैं ये लेकर रखा हूँ आप लोग को बार बार। कोई टाइम नहीं है क्या? So here, why we are using the 4 variable? Obviously A is the someone is saying that A is the present state, correct? If A is a present state, then what? Why we are using the 4 variables? Can you tell me, anyone? Why we are using the 4 variable? The other variable where it is coming?
Next state.
Yes, correct. Good. So what happened? 4 variables we are using. One is the present state, one is the next state, and 2 inputs. Okay. So if you are considering A is a present state, what is the next state symbol? We can write AT plus 1. So AT means what? AT means that current time, or T plus 1 means what? It is the next time. So what happened? Here we are denoting as a AT plus 1 is the next state. So we can write this way. This particular equation, now what happened? It is converting to in this particular fashion. A XOR, sorry, this one is the XOR symbol, X, and this one is the Y. So what happened? Using the binary combination 0, 0 to 1, 1 of A, X and the Y, and the next state we are getting this particular equation. Okay. So how we can construct the state table? It is very easy. This one is the present state. So here this one is the present state, this one is the inputs. We are considering this one is the inputs. Okay. Inputs. Okay. And this one is the next state. Okay. So present state means what? This one is the A. And inputs means what? X and Y. Because we are using 2 inputs, X and Y. Okay. And next one is the next state is what? AT plus 1. What? AT plus 1. Okay. This is very time consuming. So just we can do this one, and we can combining this one. or you can draw this one also. So just we are writing here 0 because we are using the three variables 0 1. We are writing the binary encoding pattern 0 1 0 1 0 1 0 1 and again 0 1 up to it is 0 0 to 1 1. Okay, so x means what? This one is the 0 0 1 1 0. Okay, 0 1 and 1. Next state, what is the, it is 0 0 0 and this one is 0 1 1 1 and 1. Okay, so now can you tell me how we can get the next state? Anyone?
So from the table of D flip-flop.
Yes, obviously we are using the D flip-flop. Then time what happen? We can check the properties of D flip-flop. Now, which properties actually you are looking? It is the excitation table properties. Excitation table we have to show, or normal truth state table of D flip-flop is required to get the next state.
Excitation table, sir.
Excitation table, sir.
Excitation table. So from the excitation table, how we can get? Now you can explain how we can get the from the excitation table. Okay, I will say I also confusing this one. Which particular table? So we have the present state. Okay, no problem. How you can use the excitation table? I have no idea because what you can see in excitation table you can आप लोग निकाल लीजिए जो excitation table हम लोगों ने लिखा था उसको सामने निकाल लीजिए मेरे तरफ से मनी स्लाइड को देखते रहने से कुछ नहीं होगा अपना कॉपी वगैरह सब रेडी करके रखते हैं ना क्लास के टाइम में क्योंकि कोई पार्ट मिसिंग हो जाएगा बाद में तो आप लोगों को सब ये नोट वगैरह करके रखना चाहिए ठीक है तो ये दिस इज द क्लास आप लोग नॉर्मल क्लास करने के टाइम में क्लास में क्या करते हैं वो कॉपी वगैरह आपके पास रखते हैं तो ऐसे बोलने से नहीं होगा आपके सामने यू हैव टू डी स्टेट टेबल ऑफ डी फ्लिप फ्लॉप एंड एक्साइटेशन टेबल आप दोनों आप लोग के सामने कॉपी में रहना चाहिए नाउ सी हियर इन एक्साइटेशन टेबल present states are there and next states are there and some particular flip flop if we are using SR flip flop then S and R values are there if we are using the ZK flip flop J and K values are there because T flip flop only one input and D flip flop also only one input but in this particular table see present state is there but how we can extract the next state because next state value is not absent here the value of next state is absent here so how we can get the next state from the excitation table आप लोगों ने बोला अभी थोड़ा देर के पहले एक्साइटेशन टेबल बोलिए मुझे मालूम नहीं है आप लोग बोलिए एक्साइटेशन टेबल कैसे करेंगे कैसे नेक्स्ट स्टेट का वैल्यू कैसे निकालेंगे एक्सप्लेन दिस वन
सर
यस
सर ऊपर वाला फॉर्मूला है उससे भी तो कर सकते हैं ना एक्साइटेशन टेबल की जरूरत क्या है at plus 1 equals ax or xx or y
okay what is your name
उद्देश्य राज
okay anyone okay आप थोड़ा म्यूट थोड़ा बंद कर दीजिए मैं बोलूंगा next anyone which particular table we are using excitation table or state table of D flip flop or what Uddesh is saying that means we are using the equation which one
we can use the state table and Udesha is telling the equation I think so we can use that so
यूज दैट नहीं ये कंफर्मेशन चाहिए अभी इतना सारा क्लास हो गया 30 क्लास ऑलमोस्ट कंप्लीट तो आप लोग इसमें डाउट होने से नहीं होगा होना चाहिए मे बी दिस टाइप ऑफ वर्ड्स आर इट इज नॉट नॉट यूजफुल ओके होना चाहिए सर यही होगा ये ऐसे बोलना पड़ेगा आपको see here, you know, when we are using the state table, excitation table, we cannot use here. It is not possible. State table also we cannot use, because what happen, state table, when you are getting the any particular flip flop value, suppose if we know the value of DA, then you can obviously whatever the value DA is coming, then that same value is occurred in the next state. You can check the state table of D flip flop. Okay, but unfortunately what happened here, DA is missing. Okay, so what Udesh is saying, it is correct. Okay, so see here, obviously AT plus 1, so what happened, DA we can write in the form of AT plus 1. AT plus 1 means what? It is the next state. So already what happened, how we can extract the AT plus 1, the formula is given, and also whatever the variable we are using in that particular formula, all the values are already we can assign. We know the value of A, we know the value of X, and we know the value of Y. So it is very simple. So what happened here, the output is, if we are 0 0 0 0 XOR with 0, and after that what happened, 0 XOR with 0, we are getting 0, and again 0 XOR with 0, that means what, this one is 0. 0 0 0 XOR A, this one 0 and 0. If we are using the XOR gate, 0 and 0 XOR with 1, this one is what, 1. 0 1 0 XOR with 1 means what, 1, and 1 XOR with 0, this one is also 1. So we can write something like that, 0 1 0 0. सबका समझ में आ रहा है कि नहीं हो रहा है?
Yes, sir.
Yes, sir.
Okay, so just you carefully check what that means, what type of information provided by the example, and how we can extract. So because what happen, if you are correctly draw the state table, okay, you can find out all the values of state table, then your answer may be right. From the state table you can easily derive the state diagram, you can easily derive the also circuit also. Okay, so what happen, suppose state equation is not given, only the circuit is given, so you can know how to extract the equation from the circuit. Okay, so what happen, all are interconnected with each other. Someone is missing, then how we can extract that one? Sometimes what happen, circuit is given but state equation is not given. Sometimes what happen, maybe state table is there, sorry, state diagram is there. So from the state diagram you have to construct the state table, and from the state table you can construct the state equation. So constructing the state equation, how we can use, which technique we are using? We are using the K flip flop. Okay, that, so what happen, theoretically ये आप लोगों को समझने से नहीं होगा, so practically आपको समझना पड़ेगा. Practically करने के लिए क्या करना पड़ेगा आप लोगों को unsolved solve problem करना पड़ेगा बुक से, टेक्स्ट बुक से, ठीक है. Now we can easily construct the state diagram. How we can construct a state diagram? See here. So how many values of present state? Only one value, and this one is the X and Y input. So present state, we are not using two variable. If we are using the two variable, that time obviously we are using sub 2 to the power 2 means what? We are using the only 4 state we are using. But here present state is denoted only one variable. That means we are representing the present state in this particular example only one variable. Okay, so what happened? A is either 0 or 1. So we are using only two state. One is we are assigning as a 0, and one is we are assigning as a 1. Okay, so you can check this one is correct or wrong. If I am drawing this one 0 1, sorry, 0 1 1 0, okay, and this one 0 0 1 1, and this one okay, 0 1, and this one we can use the comma 1 0 and this one we are using 0 0. Okay, 0 0 and 1 1. Now if any doubt, then you ask me. So this is the state diagram.
सर
Yes.
सर हमने लास्ट क्लास में जेके फ्लिप फ्लॉप किया था, 2 जेके फ्लिप फ्लॉप, 2 ए एंड बी आरडिक इनपुट एक्स। हाँ, तो उसका हमने स्टेट टेबल से हमने वो जे नेक्स्ट स्टेट निकाला सर, AT + 1। सर हम उसको तो इस तरह के इक्वेशन से भी तो निकाल सकते हैं, AT + 1 = x a bar + b a।
कौन सा, ये वाला?
हाँ, इसका वो इक्वेशन में एक में बिठा के निकाल सकते हैं क्या? इसका या सिर्फ स्टेट टेबल ही यूज होगा?
No, see here it is okay. So in this particular case, whatever we are using the JK flip flop. हम लोगों ने यहाँ पे क्या यूज किया है? JK flip flop यूज किया है, ठीक है? So whatever JK flip flop means what? We are using the here how many variables we are using, because obviously whatever if we are using the JK flip flop, the question is specifically mentioned we are using only 2 JK flip flop. तो 2 JK flip flop का क्या होगा? एक flip flop का आउटपुट होगा A, दूसरा flip flop का आउटपुट होगा B। So इसलिए हम लोगों ने प्रेजेंट स्टेट में ए बी लिखा।
हाँ,
ठीक है, ठीक है। तो
हाँ,
इसमें क्या होगा? हाँ, इसमें इनपुट क्या दिया है? ओनली 1 इनपुट है, इसमें 2 नहीं है। ए बी इनपुट नहीं है, लेकिन एक्स है। हाँ, एक्स इनपुट हुआ। सो सी हियर, सो ए बी एक्स जब हम लोग को मिल गया तो हम लोग क्या निकल सकते हैं? बोलो, नेक्स्ट स्टेट निकल सकते हैं। लेकिन यहाँ पे तुम्हारा जे ए के ए और जे बी और के बी का वैल्यू यहाँ पे नहीं है, और नेक्स्ट स्टेट का वैल्यू नहीं है।
हाँ,
तो हम लोग क्या निकल सकते हैं? पहले अभी नेक्स्ट स्टेप तो नहीं निकल सकते हैं। इक्वेशन से क्या करना पड़ेगा? हम लोग को जे ए के बी और जे बी और के बी का वैल्यू निकालना पड़ेगा, ठीक है? तो इसीलिए हम लोगों ने क्या किया, इसको ये जे ए सॉरी जस्ट हियर वी कैन पुट द वैल्यू ऑफ बेस्ड ऑन दिस पर्टिकुलर इक्वेशन, ठीक है? ये जे ए के ए और हाँ जे ए के ए और जे बी और के बी का वैल्यू हम लोगों ने निकाल लिया। अभी देखिए, जब हम लोगों के पास प्रेजेंट स्टेट है और जे ए का वैल्यू है, सो देखिए ये प्रेजेंट स्टेट अभी इस सीक्वेंस में मैं पकड़ूंगा, ए का वैल्यू 0 है सपोज, और बी का वैल्यू क्या है? 0 है, ठीक है? 0 है। और जे ए का वैल्यू क्या है? जे ए का वैल्यू सपोज 0 है। जे ए का वैल्यू ये 0 है। तो क्या होगा? हम लोग क्या करेंगे हम लोग? जे ए के बी। आप देखिए स्टेट टेबल ऑफ जेके फ्लिप फ्लॉप, अभी एक्साइटेशन टेबल देखने की जरूरत नहीं, स्टेट टेबल ऑफ जेके फ्लिप फ्लॉप। जब जे का वैल्यू 0 होगा, के बी का वैल्यू 1 होगा, और ए का वैल्यू सॉरी यहाँ पे हम लोग बी का वैल्यू नहीं पकड़ेंगे, बिकॉज वी आर कंसीडरिंग ओनली ए
फॉर
सो
80 + 1।
फॉर 80 + 1। सो क्या करेंगे हम लोग? ए का वैल्यू 0 लेंगे, और जे ए का वैल्यू 0 लेंगे, और के बी का वैल्यू कितना? सॉरी के बी नहीं, सॉरी ये अच्छा सॉरी ए का वैल्यू क्या लेंगे? 0 लेंगे, ठीक है? और एक्स का वैल्यू क्या लेंगे? 0 लेंगे, ठीक है? और जे ए का वैल्यू क्या लेंगे? बी का लेकिन हम लोग नहीं देखेंगे अभी, ठीक है? तो ये 0 लेंगे। तो हम लोग इजीली वी कैन फाइंड आउट द वैल्यू ऑफ 80 + 1 फ्रॉम द स्टेट टेबल ऑफ जेके फ्लिप फ्लॉप। जेके फ्लिप फ्लॉप का स्टेट टेबल में क्या दिया है आप देखिए, आप लोगों को नहीं निकालने से नहीं समझ में आएगा ना। सामने रखिए,
देखा सामने ही है, 0 0 0 नेक्स्ट इज 0।
तो क्या होगा? नेक्स्ट स्टेट क्या हो जाएगा? हम लोग का 0 हो जाएगा, ठीक है? तो इस हिसाब से क्या होगा? हम लोग ये वैल्यू जो 80 + 1 का वैल्यू यहाँ पे हम लोग डिराइव करेंगे। बट रिमेंबर वन थिंग, दिस पर्टिकुलर टेबल इज इजी if you are concept is your cleared, otherwise what happen, आप लोग 20 में देखेंगे, इसको मतलब ट्राई नहीं करेंगे तो ये टेबल हार्ड हो जाएगा। ये बहुत मिसमैच होता है, बिकॉज व्हेन वी आर कंसीडरिंग ए ओनली यू कैन चेक द वेरिएबल ए। यहाँ पे ए देखना पड़ेगा और जे ए देखना पड़ेगा। के बी अगर देख लेंगे तो आपका ये गलत हो जाएगा।
के फॉर डी, एक्स और के
हाँ सॉरी ये जे, हाँ जे ए, ठीक है? जे ए देखेंगे ना हम लोग, जे ए और उसका ये देखेंगे, के बी देखेंगे ना, सॉरी जे देखेंगे।
हाँ, जे के लिए 80 एक्स और ए। समझ गया।
अब उसको ठीक से अब मैं जैसे दिखाता हूँ वही चीज को आप लोग को क्लास खत्म होने के बाद खुद ट्राई करके देख लीजिए, तभी आप लोग को समझ में आएगा। ठीक है, तो इसमें
हाँ,
प्रेजेंट स्टेट कौन सा हम लोग कौन सा लेंगे? प्रेजेंट स्टेट जब 80+1 के लिए निकालेंगे, प्रेजेंट स्टेट एक ही कंसीडर करेंगे, बी को कंसीडर नहीं करेंगे, सिर्फ ए को ही कंसीडर करेंगे।
फॉर JA।
नो, आई एम टॉकिंग अबाउट द प्रेजेंट स्टेट। सो सी द स्टेट टेबल, प्रेजेंट स्टेट में क्या है, ए और बी है ना। सो सिर्फ व्हेन वी आर कंसीडरिंग द 80+1, डोंट कंसीडर बी, ओनली वी आर कंसीडरिंग द वैल्यू ऑफ ए, दिस वन।
हाँ, समझ गया।
ठीक है, बी को लेंगे तो बी किसके लिए होगा, BT +1 के लिए होगा। B for next state BT+1 and A for next state 80+1. Are you getting?
Yes, sir.
ओहो, sorry. हाँ, इसमें मैं थोड़ा ये हो गया था. This is what this one is what? I'm also confusing. This one is what? Can you tell me? This is not a KB. Remember, JA and KA. मैं थोड़ा लिखने में गलती कर दिया. JA and KA, and this one is the JB and KB.
हाँ.
Are you getting my point? So
Yes,
आपको क्या लेना पड़ेगा? Input भी आपको देखना नहीं है. Just you can consider A, and you can consider JA value, and you can consider the KA value. So automatically you can extract the 80+1 value. Same thing when you are considering this one, you can consider A value, and you can consider JA value. JA value is 1, and KA value is 1. अगर you can check the state table of JK flip flop when JA equal to 1, J value is 1, and K value is 1, and what our present state is 0. What is the value is coming? Oh, no, what is the
next state 1?
So
1
here
x equal to 1.
Here I am writing here 1. समझ में आ गया?
हाँ.
तो इस हिसाब से हम लोग बाकी का वैल्यू भी निकालेंगे, और सेम प्रोसेस से हम लोग का BT प्लस का 1 का भी वैल्यू निकालेंगे. तो इसमें what happen? इसमें how many present states are there? Obviously 2, A and B. And what is the how many bits we are using in next state? 2 value, 80+1 and BT plus 1. So for that particular purpose, in every state we are using 2 bits, 0, 0. But in this question, see here, in this question only present state is only 1. That means only A. Here no, we are not using any other variable for present state, because this particular equation cannot permit us. Not this particular equation not permitted to give the 2 variables for present state. So for that particular purpose, what happened? In this particular state we are using only 0, and this particular state we are using only 1 bit. Okay, so see here, when 0, 0, okay, and if when 0, 0, suppose present state is now 0, and when we are providing the input 0, 0, see here input 0, 0, that means in this particular first sequence, what is the next state? Next state is 0. So I am using this particular self loop. And same thing, see here, when 0, 0 and 1, 1, which one is 0, 0 and 1, 1? This one is 0, 0 and 1, 1. Then we are getting the same next state. So the input is 0, 1, 1. But when 0, suppose right now we are in 0. Okay, suppose this one. And suppose we are providing 0 and 1 as an input. So this one is the 0 and 1. This one is the 0 and 1. Okay, that time what happen? Where we are going to the next state as a 1. So what happen? We are using this particular cursor, this particular direction. So this one is 1. So 1, suppose our present state is 1, this one is the 1, suppose. And if we are using 0, 1, suppose input is 0, 1, then what is the next state? Next state is 0. So we are using this particular direction. Okay, so what happen? If 1 and 0, 1, suppose 1 means what? Right now the present state is 1, and if we are applying the 0, 1, that time what happen? What is the next state? Next state is 0. So everything is clear from the state table, and based on the state table we can derive this particular state diagram. ठीक है?
हाँ sir.
Yes, sir.
Yes sir.
Okay. So Okay, if when we will take some particular doubt session or remedial class, and some students are interested to have some particular doubt, after completing the syllabus, I will take 2 and 3 classes. Okay, that time you will ask in, but remember one thing: these particular examples are not sufficient. You will work, you will try more examples. Otherwise, what happen, your concept, sometimes what happen, yes, you know theoretically, but what happen when you are doing that time, what happen, some problems are occurred. So you know how we can construct the state table of any flip-flop, how we can construct the excitation table of any flip-flop. Okay, sometimes state table is required, sometimes excitation table is required, sometimes equation also required. Okay, and it is not sure from the question which particular part is already given, because they are all interconnected with each other. Okay, so you can carefully check all those things. So today is the 30 class. Class have already completed more than 30 class, but I am not maintaining the sequence. Now what happened? Because without the concept of flip-flop, without the concept of state table, without the concept of state equation, we cannot design the counter. Okay, now you know how we can use the how we can from the state table, how we can construct state diagram or state equation. Okay, so what happened, another is called a sequential counter. This one is called a sequential counter, or is a one type of sequential circuit counter. Okay, counter means what? It is just we can check how flip-flops are actually working in proper manner with the base of time. Okay, because what happen, you know, when we are using the flip-flop, that time what happen, we are by default we are using the clock flip-flop. So based on the time signal of or clock signal, how this particular flip-flops we are interconnected together such that they are giving some meaningful information. Okay, see here, the counter is a set of flip-flop. Okay, so when we are constructing the counter, we are using the flip-flop, and flip-flop is what? One type of memory elements which is capable to store the 1-bit information. One flip-flop store the 1-bit information. Okay, so the counter is a set of flip-flop which changes the state of their pulses and directly applied to the clock. So when we are applying the clock signal, that time what when based on the flip-flop, we are moving to the one state to the another state. Okay, some meaningful way. Okay, the flip-flops are interconnected with each other. So constructing the counter, the flip-flops are interconnected with each other, such that binary equivalent is the total number of pulses that have occurred up to that time. So what I can see here, a few seconds ago, I am telling that in meaningful way. What is the meaningful? That means what? When we are applying the clock signal every time. Okay, so flip-flop based on the clock signal, flip-flop giving the some information, and that particular information directly related with the time signal. Suppose if you are applying the 4 timing signal or 4 clock pulse, okay, after some particular interval, that time what happened? So binary, we can counting the binary, that particular timing signal is equivalent to the binary. Okay, suppose if we are using the 3 clock pulse, that time what happened? The flip-flops providing 0, 1, 1. If we are providing the 4 clock pulse, that time what happened? The time signal, the flip-flop is showing the output 1, 0, 0, something like that. Okay, but so the name is suggested that this one is counter. So counting the timing signal. Okay, so many cases, many applications where this particular counter is required. Okay, and counter is basically the sequential circuit. So there are two types of counter. One is asynchronous counter, also it is called a ripple counter, and another one is the synchronous counter. The ripple counter is the simplest types of the counter, the easiest to design and required less amount of hardware. That is the advantage of the asynchronous counter. Okay. The flip-flops within the counter are not made to change the state at exactly same time. Okay. After that, the clock to the flip-flop use are not common, and this is because flip-flops are not triggered simultaneously. So that means what? This particular second point, this particular point is very important. So when we are using the asynchronous counter, always remember all the whatever the flip-flops, because one particular clock we are applying to the one flip-flop, because that is the clock flip-flop. And when we are another flip-flop, if we are using, obviously there are also one particular clock signal is required. But remember, when we are applying the timing signal, okay, that time what happened? The clock are not common to the all the flip-flop. That means the same clock are not affected all the flip-flops. Okay, because all the flip-flops have a different clock pulse. So this is because, see here, this is here after that you see the last sentence. This is because the flip-flops are not triggered simultaneously, because we are using the different clock pulse to the different flip-flop in asynchronous counter or ripple counter. Okay. So how we can use the clock pulse? See the last point. Asynchronous ripple counter is constructed with the JK flip-flop. Generally, we are using the JK flip-flop. Okay. Why? Where toggle condition is used. So why we are using the toggling condition? You know what is the toggle? Toggle between what? It is 0 and 1. 0 and 1. Okay. So obviously what happened? It is 0 and when the 0 and 1 is occurred, that time what happened? We can apply the clock pulse. One time is 0, one time is 1, one time is 0, one time is 1. Okay. So for that particular purpose, what happened? We are using the JK flip-flop. So generally what happened when we are designing the asynchronous ripple counter, we are using the JK flip-flop because of toggle conditions are appeared in JK flip-flop. And external clock pulse is applied to the first flip-flop, then output of the flip-flop is connected to the second flip-flop as the clock and so on. So whatever the output is coming from the first flip-flop, that particular output behave like as a clock signal of the second flip-flop. But remember, you know, when we are using one particular flip-flop, when we are using any flip-flop, there are two outputs. One is A and A bar. And A is behave like as a clock to the next flip-flop, or A bar is a behave like as a clock to the next flip-flop. That particular, we'll see later. Okay. Now what happened? Based on asynchronous counter, there are two types of asynchronous counter. One is called a up counter and one is called a down counter. Okay. So what is up counter and what is down counter? And when we are using the up counter and when we are using the down counter, there are some particular conditions are given. Okay. This is the up counter condition and this one is the down counter condition. Okay. If we are using the up counter and if we are using the positive edge trigger, okay, remember, if we are using the asynchronous counter and after that asynchronous up counter of asynchronous counter and that particular counter have a positive edge trigger, that time what happen? Q bar as the clock to the next flip-flop. Okay, we will check the diagram. Okay, so that means what? Why we are using the Q bar? Because positive edge means what? Positive edge, it is going to 0 to 1. Okay, every time clock timing, when we are moving from 1 to 0, that time what happen? Timing signals are not changed. Okay, we are not counting that particular timing signal. So what happen? Positive edge means what? It is the not a leading edge, it is the trailing edge. So this one, this way. Okay, and when we are using this particular 0 to 1, that time what happen? It is 0 to 1, and that time what happen? If we are connecting the Q bar as a clock, that time what happen? Every time this one is active in Q bar. But remember, if we are using this way, that time what happen? Flip flop is not active. That means that we are not active the clock pulse. For that particular purpose, we are using as a Q bar as the clock to the next flip flop. Suppose if the flip flops are negative edge, then just it is opposite. We can connect Q as the clock to the next flip flop. Okay, this is the case for up counter. And down counter also we are using similar, just opposite. You remember, if you remember for up counter, then you can also design for down counter also. Suppose if we are using the down counter means what? Now clock is we are considering as a this direction. Every time when this, that means what? It is the trailing edge, not a leading edge. Okay, so when positive edge triggered occurred, that time what happened? Instead of Q bar in up counter, down counter we are using Q as the clock to the next flip flop. And if you are using the negative edge triggered, that time what happened? Q bar as the clock to the next flip flop. So this is the part of asynchronous counter. Now this is the asynchronous counter, but what about the synchronous counter? Okay, so just a minute. Synchronous counter are clock such that in the counter is triggered at the same time. This is accomplished by the by connecting the clock line to each stage of the counter. Okay, and synchronous counter are faster than asynchronous counter because the propagation delay involved less time. The delay of propagation is less as compared to the asynchronous counter. So from this is how we can differentiate what is the main difference between the asynchronous counter and synchronous counter. So always remember, when we are using the asynchronous counter, that time what happened? Flip-flops within the counter are not made change the state exactly at the same time. Okay, but when we are using the synchronous counter, that time what happened? All the signals are, that means all the changes occurred in the counter at the same time. But when we are using the asynchronous counter, it is not occurred at the same time. It is occurred different time, because the clock signal of every flip-flop is different in asynchronous counter. So synchronous counter means what? The same clock pulse affect all the flip-flops at the same time. Okay, that is the main difference between the asynchronous counter and synchronous counter. And also, see, when we are using the synchronous counter, that time what happened? Because we are applying the same clock pulse to all the flip-flop, so propagation delay is less, or delay time is less than the asynchronous counter. So it is very basic question, very popular question, also very basic question. What is the difference between asynchronous counter and synchronous counter? You remember this one. Okay, any doubt? Any doubt?
Sir, sir, propagation time is delayed in synchronous counter.
No. Propagation time is less in synchronous counter. So it is very fast. Synchronous counter is very fast than the asynchronous counter.
Okay.
Why? Because see here, in synchronous counter, the same clock pulse we are applying to all the flip-flop. Okay. But when we are using the asynchronous counter, at time what happen, all the flip-flops have a different clock pulse. So what happen, delay time is more than the synchronous counter. ठीक है. So delay time किस में कम होगा? Asynchronous counter में ना synchronous counter में delay time कम होगा. Are you getting my point?
Yes, sir.
And one thing also you remember, when we are designing the counter, that time what happen, one particular thing is very important. One particular part, one particular word you can generally face. This one is the called mode. Mod 8 counter, mod 5 counter, mod 3 counter. What is this one? Okay. Suppose when we are using the mod 8, that time what happen, we are, how many flip-flops actually we are using mod 8 counter? So how we can define? This one we are defining like that. Suppose 2 to the power 3. So when we are implementing the mod 8 counter, maybe it is asynchronous counter or synchronous counter. Suppose if we are assuming that if we are using asynchronous mod 8 counter, that time what happen? How many flip-flops is required? It is 3 flip-flops are required. Because 8 means what? 2 to the power 3. Suppose if we are using the mod 5 counter. So mod 5 means what? We cannot use the 2 to the power square, because 2 to the power 2 means what? It is 4, and 4 is less than 5. So what when to design the mod 5 counter also, it is required 3 flip-flops. Okay. Mod 8, mod 10 counter. Mod 10 counter.
4 flip-flops.
Yes, it is 4 flip-flops. Okay. Now we are directly going to some particular example. Suppose yes. Just a minute, huh? Now we are going to design mod 8 asynchronous counter. Okay, so we are right now we are not talking about the synchronous counter, we are talking about the asynchronous counter. Okay, this one is the asynchronous counter. So hence modules of the counter here what 8. So total number of flip-flop is what? N equal to 3. So how many flip-flop we are using? We are using the 3 flip-flop to design the mod 8 of asynchronous counter. So obviously that time when we can design 3 flip-flop. This one is the 1 flip-flop. This one is the other flip-flop. And this one is the other flip-flop. So you can say this one is the flip-flop number 1. F, F, F1. This one is the flip-flop number 2. Okay. And this one is the flip-flop 3. So if we are using the JK flip-flop, that time what happen? We are using J input. This one is the J. And suppose this one is the K. Okay, K. And this one is the clock signal. So what happened here? All the clock signal we are connecting. So this one is what? This one is J. And this one is also J. And K. K we are connecting. We are connecting here also. We are connecting here also. Okay. And this one is what? This one is the Q1. And this one is the second one is the Q1 bar. And this one we are denoting as a Q2. And here this one are also Q2 bar. And this one is the Q3. And this one is the Q3 bar. Now see here, in this particular asynchronous counter, we are using up counter because here it is specifically mentioned mod 8 up counter. So you can check the condition. If we are using the up counter, that time what happen? Q bar as a connected to the next flip-flop. So what is the Q bar as a clock pulse? We are connecting as a next flip-flop. So Q bar we are directly connecting to this one. Okay, and also what happen? This particular Q2 bar, this Q2 bar also we are connecting as a next flip-flop. That's all. So this is the circuit we can easily design. So what happen? What is the advantage of this one? So we can easily design. So because this one is the up counter, so what happen? Q bar of the first flip-flop, the Q bar Q-1 is the output of the first flip-flop. We can connect as a next flip-flop of FF2. Again, what happen? The output of Q2 bar is a connect as a clock pulse of the flip-flop number 3. Okay. So when we are talking about the up counter means what? What exactly the up counter? See here. If you are the how the, that means timing diagram actually it is behave. Okay. Suppose see here. So this one is the clock pulse. Suppose I am using this one is the CP. CP means what? Suppose clock pulse. Okay. And this one is the direction this way. This one is the direction of this way. This one is the direction from the trailing leading edge. This one. This one. This one. You can try this. Okay, this way. Suppose we are considering initially we are considering j equal to 1 and k equal to 1. Why? Because we are using the toggle condition. So suppose what happened when the before starting the clock pulse, the value of j is 1. This is the j value and k value. This one is the k. K also what happened u1. So just this one is the 1. That means what? It is going high. So this one is 1 and this one is 1. Okay. Now see here. So this is the positive edge clock pulse. So this one is what happened? Timing clock pulse is starting here. The time interval is here. Okay. Next time interval is what? This one. Because it is the positive edge trigger. Okay. So this way we can. So this one is this one. Okay, this one is this one. Just you can remember this one. Oh, okay. Now see here. Q1. Suppose if we are using Q1. Okay, Q1 means what? So this one is the Q1, Q2. Because if we know the Q1, then automatically we know what is the Q dash 1. So if Q1 is 1, then Q dash 1 means what? It is 0. It is the complement form. So what happened here? When the first clock pulse is occurred, that time what happened? What is the value? The value of Q1. That means that the timing is behave like this way. It is behave like this way. Sorry. Okay. Just a minute. It is going this one. This one, this one, this one, this one. Okay, just a minute. It is okay. So this one, this one, this one, this one, this one, this one. Okay, because the clock pulse is changed here. The clock pulse pulse is changed here. This change here. Change here. Okay. Next, the Q2 value. See here, Q2 value. What is the Q2? Q2 value is occurred this way. Okay. And Q3 is something like that. Okay. Sorry, and this one is the, this one we can change here, this one we can change here. Okay. So this one is something, this one is this. Don't use this one is wrong. We can use. Are you present? All of you present?
Yes, sir.
Yes, sir.
See here, in the first clock pulse in this particular timing diagram, based on this above diagram. So what happened? We are using the up asynchronous counter. Up means what? We are using the positive edge. So what happened when we are moving from 0 to 1, this particular part, that time what happened? Clock pulse is starting. And what is the interval of the clock pulse? This to this. So when this particular circle is completed, that time what happened? Next clock pulse is started. So this one is dot dot dot. So earlier I am saying that when generally what happened when we are using the asynchronous counter, if we are using the ZK flip flop, that time what happened? We are using the toggle condition. So for that, you know what is the value of J and K, how the toggle condition is occurred when J equal to 1 and K equal to 1. So for that particular purpose, what happened? We are, before the timing diagram starting, that means what? J value is 1. So this one is 1. So all are high. And also K is also 1. So K is also 1. This one is high. Okay, this one is high. Now see here, when the clock pulse is started, what is the value of Q1, Q2 and Q3? This one is starting here. This particular clock pulse is starting here. That time whatever it is going the down direction. And this one is the up direction. Okay, then what is the value of this one? This one value is 0. And also this one is going, Q2 value also going the down direction. Then what happened? This one is also 0. And Q2 also going the down direction. Then this one is also 0. When the second clock pulse is started, which one? This one is the second clock pulse. That time what happened? Q1 value is 1. And again it is a low direction. So it is 0. Q2 value. And Q2 value is also 0. Okay. So if we are again we are going to this one, that time what happened? This one is 0. This one is 1. This one is 0. Again what happened? This one is 1. This one is 1. And this one is 0. When we are going to this one is 0. This one is 0. And this one is 1. So this one is 1. This one is 0. This one is 1. This one is 0. This one is 1. This one is 1. Okay. And all are this one is 1 1. So how this particular timing signal actually form based on this particular timing diagram? If you are considering this particular fashion, see here, this one is 0 0. this one is 001, this one is 010, this one is 011, and this one is 100. So we can write this way. Every time what happens, the output of the flip-flop C, it is the, what is the time interval? So first interval is, this one is starting from 0, so it is 00. The second clock pulse, when we are applying that time, what happens, this one is 001. Third one is what, 010. So it is up to what? It is up to going up to it is up to 111. So what when you check the definition? Which particular definition? Second statement. The flip-flop within the counter are not made to change state at exactly at the same time. The clock flip-flop are no, this one is not. Oh yes, this one. The flip-flops are interconnected with each other such that binary equivalent is total number of pulses that have occurred up to that time. So that is, so here, see here, how many flip-flops? This is the number of 0, 1, 2, 3, 4, 5, 6, 7. And when we are applying this particular clock pulse, this one, the last one, that time what happens, see what is the value? Value is Q1 is 1, Q1 is 1, Q2 is 1, and Q3 is 1. So we are getting 1, 1. So it is one type of counting from, and it is going from 0 to what? If we are considering the decimal equivalent 0, 0, 0, 0, sorry, 0, 0, 0, 0 to, it is going to which particular direction? It is going to 7, up to 7. Okay, so it is going from 0, 1, 2, 3, 4, 5. So it is the increasing order. So for that particular purpose, it is called a up count. If when we are using the down counter, if we is going to 7 to 0. So that time what happen? This one is the down count. Any doubt? Any doubt?
Sir, for down counter, Q will be the clock for F.
Yes.
FF2.
Yes. Instead of suppose up counter, if I am using the down counter, so, okay. Down counter. That time see here, this Q-1 is not a clock pulse. This Q1 is the clock pulse to the next flip flop. Q2 is a next clock pulse of this particular flip flop. Are you getting my point? Because down counter, so you can obviously check the condition, but what happened based on this particular timing diagram is totally changed. So what happened instead of 1 1, so what happened, this one is coming as a 1 1. So this one is the high. We can use this way. We can use this way. Okay. So first part is we can use this one, something like that. So all are 1 1. So it is moving from 1 1 to 0 0.
Okay. So binary sequence count Q3 से Q1 तक करना है ना?
Yes, Q1, because what happened here, how many outputs are we are using the 3 flip-flops, then obviously 3 outputs are there. Obviously, because what happened, this one is the Q1, Q2, and Q3. Okay, but obviously Q-1 also output, but what happened, if you know the Q1, then you can know the value of Q-1 because it is the complement from. Okay, so if it is 0 0, I am using the 0 0 0 0, then only we can consider only one particular output, because if it is 0 0, then what is the next output here? Here actually this one Q-1 we are not considering as the output, because it is now right now it is behave as a clock signal. Are you getting my point?
Yes.
It is behave like as a clock signal to the next flip flop. This Q2 is a, so what happened, we are considering only Q1, Q2, Q3. Suppose if we are using the down counter, that time what happened, what is the output? Output is Q-1, Q-2, Q-3.
Okay.
Any other example? Or example कहाँ पे होगा? So if you are more clearly, if you the count step, suppose if you are countable, suppose when is the counter, So based on the timing diagram, we can use the count table. This one is what? Count table. COUNT, count table. So okay, this one is the count table. So this one is, first one is the count state. Count state. Count state. And this one is the count. Okay, suppose here this one is the Q3. Okay, Q3, Q2. This one is the Q1. Okay, so count state means what? This one, the first count state 1, 2, 3, 4, 5, 6, 7. So how we can write? You can write 0, 0, 0, 0, 0, 1, and up to whatever you can write up to 1, 1, 1, 1, 1. So whatever it is increasing order, so it is called a up counter. So this one is the increasing order, so it is called a up counter. Okay. So suppose you can try, yeah. Up counter and down counter means what? Only you can change the interval based on the, if it is going the positive to negative, that time what happen? If we are using the up counter, that time what happen? The clock pulse is started. Okay. So when it is coming from 1 to 0, the clock pulse is not started. Okay, that means we are not counting that particular signal. Okay, and when we are using the down counter, that time what happen? It is moving from 1 to 0. That time what happen? The clock pulse is started. That is only difference between the up and down counter. Okay, but counting the plus is counting the sequence. The counting the sequence is same. That means we are maintaining the same order. So same question. If we are using the down counter means what? If we are using the down counter, suppose you write one particular question, right? Design a up counter. Design a up counter. Design a up counter. Within bracket you write mode 8. आप लोग लिख रहे हैं ना? मैं जो बोल रहा हूँ.
Yes, sir.
Design a up counter. Within bracket you write mode 8. Okay. After that you write using negative edge triggered JK flip flop. Using negative edge triggered JK flip flop. So in this particular question, see our previous question, that means this question, design a mode 8 up asynchronous counter using JK flip flop. Here we are not mentioning any positive and negative edge. So if suppose question is coming in this particular fashion, that time what happen? By default you can use negative triggered also, edge triggered also, positive edge triggered also. But in this second question, what I am telling right now, here specifically mentioned that you are using the negative edge trigger. But it is what? It is the up counter. It is not a down counter, remember. We are using the up counter, but it is negative edge trigger using JK flip flop. So how you can construct this one? So same, what happened? It's the same figure we are using. Here also we are using the 8 because here we are using the 3 flip-flop. We are, how many flip-flops we are using? The 3 flip-flop. Okay. We are using the 3 flip-flop. And these are all the clock pulse. So check the condition. Here we are using, this one is the J and this one is the K. Okay. And suppose initially it is 1. So this one is the what? It is the, if it is flip-flop 1, suppose we are using, this one is the Q1. And this one is the what? Q1 bar. Q1 bar. So this particular Q1 is a connected pin, this one. And this particular Q2 is connecting to the next flip-flop. This one is the second flip-flop and this one is the third flip-flop. Okay. So this one is Q1 and this one is the Q2 bar. And this one is the Q, this one is the Q3. Okay, Q3 because we are using only the 3 input, 3 flip-flop. And this one is the Q3 bar. Okay. And J and K, you can connect all the flip-flop. Here also J, this one is also K, and this one is also K, and this one is also, this one is, we are connecting as a J. Okay. So when we are using the timing diagram, CP, timing diagram, see here, the output is something, the interval is something like that. This one, 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 this one. Okay. So suppose here you are 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this one is this one. And this one. This one. This one. This one. This one. Something like that. So it is only interval is starting from here because it is the negative HD card. And starting from here. It is starting from here. Are you getting my point? So this is this one. Because it is the negative HD card. Other parts are remaining same. Here also we are getting the 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 1. But what when we are only, we are considering that this particular interval, only this. This way we are designing the asynchronous counter. Okay. Suppose question is asking something like the down counter and positive edge trigger. So what happen if it is down counter? If it is down counter and positive edge trigger, that time what happen? We can connect Q as the clock to the next flip-flop. If it is down counter and if it is negative edge trigger, that time what happen? Q bar as the clock of the next flip-flop. And you can draw the diagram this way, and after that what happen? You can design the circuit. So this maybe we will check in the practical lab how these particular signals are coming, how these waveforms are created. Okay. Most probably this week your lab class will be started. Maybe tomorrow your lab class will be started in the second half. Though we will inform soon through WhatsApp. Okay, Jagannath sir inform you. Okay, so today it is okay. Tomorrow we can go for synchronous counter. now we are sick that how we are designing. Now we are we are discussing about the asynchronous counter. Okay, so tomorrow we'll check, or we'll see how we are going to design the synchronous counter. That means how we can design the synchronous counter. What is the difference between how we are going to the design process? What is the difference between the asynchronous and synchronous counter? Okay. Sina Boru Baru. Sina Baru.
Yes. Yes, sir.
No, what is your name?
Sneha.
Oh, sorry, Sina. So how many class you are miss?
सर
आपने कितना दिन के बाद ज्वाइन किया है क्लास में?
पहले किया था मैंने।
हाँ, तो 20 में क्यों नहीं किया आपने? 20 में क्या मैं क्लास नहीं किया था क्या? तो पहले किया था तो 20 में क्यों नहीं किया था आपने? आपका अटेंडेंस बहुत कम है, आपको प्रॉब्लम होगा अभी मिड सेमेस्टर में। मैंने पहले किया था, 20 में क्यों नहीं किया? मैंने बाद में क्यों नहीं किया? वही बोलिए मुझे, क्या प्रॉब्लम हुआ?
कभी कभी नेट का भी प्रॉब्लम होता है इसलिए।
नहीं, नेट का प्रॉब्लम होता है, कोई भी प्रॉब्लम होता है, वो तो नेट का प्रॉब्लम होने से कम मुझे नहीं लगता है कि ये ज्वाइन करने के लिए आपका नेट का प्रॉब्लम होगा।